How are you, boys and girls? Today we are going to continue with our work on programming. The programming work is part of paper 2. So when you are writing your notes, please remember to write this in the correct textbook. This work is going to be a continuation of the work that we did that other afternoon before midterm. So if you have not yet watched the video of the lesson that we did before midterm, please go ahead and watch that video. Otherwise, you may end up being unsure of what is going on. All right, so today we are going to continue with our story on variables. We looked at two terms. We looked at the term called the variable, and we looked at the term called the constant. We discussed what a variable is. We said a variable is a named memory location whose contents can change during the execution of the program. So these are the two terms which we looked at in our previous lesson, and you can see that the definitions are really very similar. A constant value does not change. Once you set it to some value, it will stay at that value during the running of your program. A variable, on the other side, it may change. It may change during the execution of your program. All right, so if you look at an example of, say, a school, the name of your class teacher may change during your school days. So let's say at the beginning of the term, your class teacher is Mr. Arnold. Then after some time, your class teacher may change to Mr. Joe. That's possible. So we can equate such a situation to a variable. We are saying class teacher may change from Arnold to Mr. Joe during the execution of the program. Then we have a situation where a particular value may never change. If you think of it in mathematics, we have a value called pi. Pi is going to be, it looks like this, pi. Pi is going to be 3.142, etc. for the rest of our lives. So when you are storing the value of pi within your computer program, you would rather set it as a constant. Now, sometimes we can say, I prefer to use visual aids here and there. So let's say we have a variable called teacher name. I am using the underscore notation, so please take note of that. I am going to be mixing the use of underscore notation and the use of camel case notation. So this box here represents the container or the memory location which is supposed to hold the value of the teacher's name. So the teacher's name here is going to be, say, Arnold. All right. This is an example of text. Then sometimes I might want to store the teacher's age. So I will have a container here for storing the teacher's age. All right. The teacher's age is 35. Let's suppose I'm presenting my age in years. So I'll write it as 35. This is a whole number. Now, in programming, we have a concept called data types. And what it simply means is, what kind of data are you going to be dealing with? To give you a quick overview, you might be dealing with text data. You might be dealing with numbers. You might also be dealing with data that is date or time. Date or time. These are examples of data types. So let's look at the idea of data types in more detail. The data types which we are going to look at here are what we call the basic data types. We are going to look at the basic data types. In some programming circles, this will be referred to as the primitive data types. Okay. I'm not going to mention what is the opposite of the basic or primitive data types. I hope you are going to stay around with me for long enough to learn the other kinds of data types which are out there. We'll start to see them in AS level and in A levels. So, why do we need to know these data types? When you are starting your program will need to run in the CPU. But before it gets to the CPU, your program will pass through the RAM. Now, how does the operating system know how much data your program needs or how much space your program needs? The answer lies within our understanding of data types. It's like I'm going to come to your house and maybe we are going to have breakfast, dinner, lunch together, and I'm also going to bring my friends. If I tell you that one of my friends is driving a sedan, you might have an idea of how much parking space to set aside for us. If I tell you that one of my friends is driving a bus, you might have an idea of how much parking space needs to be reserved for us. So your program needs to have an idea of how much space should be set aside for the data that makes up your program and the other data that may be put into your program during runtime when your program is running. So that's one idea why we need to know about data types. We want to set aside the correct amount of memory for the program and whatever data it is going to need during running. Okay, so let's look at the basic data types which are important for us at this stage. The first one is the numbers. Now, let me say numbers here. Now, we have two kinds of numbers to worry about. We have whole numbers. These ones are called integers. And we have numbers with decimal points, and these are called real numbers. Let me just call them real there. Okay. So these are the names of our data types in pseudocode. These are the names of our data types in pseudocode. When you go to some programming languages like Python, you may find that these data types have different names. Integers, they tend to be called integers all over. We actually call them int. And real numbers with decimal points, we tend to call them float. That is in Python and other high-level programming languages. Let's get into the definition of these two data types. An integer is a positive or a negative whole number that can be used with mathematical operators. So, when we say an integer can be used with mathematical operators, we are looking at situations where you have a number that can participate in arithmetic, like 2, the mathematical operator would be plus, another integer would be something like 3. So this is an integer. Whether it's positive or it's negative, it is an integer. So the short of it is this. An integer is a whole number, positive or negative. That's it. When you are writing integers, you give them as just a value. Let's say Arnold's age. I can say teacher age is equal to, then the integer would be 35. I want to emphasize this idea because we have other data types where the value should be in quotation marks. But for integers, boys and girls, integers are not put in any kind of quotation marks. Examples of other integers we can talk about is the number of people. If we have the number of people in a room, they are going to be a whole number. I don't expect to walk into a room with 2.5 men or 2.5 girls. No. Whole numbers, that's the number of people. The next data type which we are going to look at is the real number. Okay. Real number is a positive or a negative number with a fractional part. In other words, with a decimal point. Real numbers can also be used with mathematical operators. So these are numbers. They can be used in mathematics. Addition, subtractions, raising to the power of something, division, etc. So, real numbers are, real numbers are positive or negative numbers with a decimal or a fraction part. They can be used with mathematical operators. An example of a real number is, say, teacher mass. It's not very usual for the mass of somebody in kgs, for example, to always come in whole numbers. If you jump onto a scale right now, chances are very high the number that is going to show on that scale will have some decimal points. So, the teacher mass could be 89.9. When we are playing with numbers, we are not going to put the units over here. That's for physics. We are not going to do it here for now. So that's an example of a real number being used. right over there. You can think of a real number when you do calculation of averages. Usually when you divide numbers, they give you decimal points. That's an example of an application of real numbers. I want you to think of more examples. These are things which I'll be asking in the test. All right, so that's our real number, the second data type. We looked at integer. We have now looked at real. Let's move on to the next data type. Let's suppose I want to store my name. What data type would I use for that? I have already pointed out to a data type called text. In pseudocode programming, we are not going to refer to text as text. A little bit weird there. So, text is called string. Please repeat that word after me. String. Instead of calling it a word, instead of calling it text, they decided to call it a string. So if I'm storing your name, if I'm storing words which were said by Arnold, if I'm storing a phrase, I will store those values as strings rather than text. Name of a town, name of a favorite pet, strings. So what definition can we give to a string? Strings are variables or constants that are several characters in length. So the strings that make, the characters that make up a string, they can be alphanumeric characters. That is, characters which you get from the alphabet like A, B, C. These are alphabetic characters. You can join them with numeric characters like 1, 2, 3, 4, etc. These are numeric characters. And we can even join them with a little bit more characters, but we are going to see addition or, sorry, a joining of other characters a little later. All right, so let's look at an example of the use of a string. My name is Arnold. Now, if you are saying Arnold is the string, we will refer to it as the string value. This value must be in quotation marks. I have asked you to program in Python a couple of times, and I think you might already have come across a situation where words are supposed to be put in quotation marks. So if it is a string, you must put it in quotation marks if it's a string value. All right. For fear of bringing some confusion, let me say the following. This is the variable name. This is the variable which is holding the value Arnold. The variable name must not be put in quotation marks. Only the value must be put in quotation marks. You know it's a string value when it is in quotation marks, double quotation marks for that matter. So it is really important to take note of these. And I know it might take a while for you to grasp these concepts, but after 2 to 3 weeks, I think you should be slowly getting fluent in these ideas. All right, so that's a string. Let's move on to the next data type. And that data type is the character. A character is just one character. If you look at my name, well, I think I like my name very much. Let me write it here. If you look at my name there, I'm going to put it in quotation marks because I want to get into this gig of putting quotation marks around string values. Okay. How many characters make up my name? Let me count them for you. Character number 1, number 2, number 3, number 4, number 5, number 6. Okay, so there are 6 characters which make up my name. Sometimes you might want to store just one character. Just one character. For example, you might want to store, let's say, currency. You want to store the $sign. That's a single character which you want to store. So you put it in quotations. It should be one character. And please take note, I'm using single quotation marks. Different teachers and textbooks will teach you slightly different things. You might be asked to use double quotation marks by some textbooks, but according to Cambridge, our examiner, we should use single quotation marks on character values. Let me get to the definition of character in a little bit more detail. There is our definition of character. And you may be surprised, when did Arnold become so lazy to write it as car or a char? The reason why I write it as char is character is never written in full. I wrote it in full here because, well, we are still learning, guys, and I have to say it all. But once you become a programmer, you'll be referring to it as a char or a car, depending on your preferences. You will never write it as a character, especially in a program. You will never write it as a character. So whenever you want to store single characters, for example, if they say, Arnold, give us your initial, I can say initial is A. That's my initial. I'm not going to say AD. I'm just going to give that one to fit the narrative. All right. So when you are storing single characters, you store them in a variable of data type char or a char. All right. So think of situations where you would use the character data type. I've just given you when storing initials, when storing, say, currency. Can you think of more? Please share those examples with me in the classroom when we meet. Then we have another data type called Boolean. So this was number maybe 5. We have a data type called Boolean. That's a new one. Okay. We have situations in programming where you want to store either yes or no. Those are the only values you want to store. For example, if you come to me and you say, Arnold, are you happy? You may be expecting only two kind of answers, a yes and a no. And for me, when I'm teaching you, the answer is yes. So, Boolean is a data type which can only store two values, a yes or a no. And we are going to spice things up a little bit in programming. Instead of saying yes, we are going to say true. And instead of saying no, we are going to say false. So Boolean is used in yes, no situations. I want you to not use the word yes, no, but use the words true, false situations. Okay. There is a situation where we are going to emphasize the use of yes or no. But when you are programming in pseudocode, in Python, we are going to be using true or false. So let's define Boolean. There you have it. So if the only values which a variable can store are true or false, then we use the data type called Boolean. Okay. Let's give an example of the use of Boolean. Like that. Is the teacher happy? True. I just finished marking your work and your homework, and lots of you got 90s and 95s. Two of you got 100%. A number were 85, 80. I'm a happy guy. So when your answers can only be true or false, then you store it in a data type called Boolean, or a data type of type Boolean. Then lastly, we are going to look at when you want to store dates and time. What data type do we use when we want to store dates and time? It's called a date or time data type. We use it to store date or time variables or constants. So that's the date time data type. For example, my birthday. My birthday is on 7 September 19. Well, I don't have to put the year if I'm talking just about the birthday, but when you are giving your value as a date time, must follow this convention. Please pay attention. You say day, in other words, you must have two values to represent the day you were born. Then we put the forward slash, and we should have two values for the month you were born, and forward slash, and we put 4 values for the year you were born. So we are going to have 4 characters for the year you were born. This is the correct syntax for date time. If I say put a value on my birthday and you say 7 September 1990, using this format, it will not be accepted, unfortunately. This is the only format which is accepted by a data type of date time. So these are the different data types we need to be familiar with.